In the last video, we explored what flags were and how to get JavaScript values into our Elm program on initialization. We very lightly explored decoders, which take those JavaScript values and turn them into Elm primitives that we can use in our program. But it was a very simple example and there's much more to know about them. So in this video, we're going to learn how to decode much more complicated JavaScript values. We're going to hit an API, we're going to get some JSON back, and then we're going to initialize our Elm program with that JSON and decode it into some sort of useful data structure that we can use. You are going to fully understand decoding after this video, I promise. So let's get relaxed and comfortable and let's check it out. So we're going to be using our program from the last video. Let's just go over what we did real quick. Here in the index.ts, we are initializing the Elm program with a query to see if the user prefers dark mode. And this value gets sent straight into our Elm program on startup. In our program, we are looking at our init function here. We take those flags, which is the JavaScript value for prefers dark mode. We know that's a bool. So in the function, we can see that we're decoding that value to a bool. This gives us a result that we switch on. And if the result's okay, then we set that value on the ready model. And if this decoder happens to fail, then we set our model as an error, and then we can actually render something on the screen in case it's an error. Let's actually just run this program and just make sure everything's working. From the command line, we can run pnpm parcel index.html, and looks like something's going on at localhost 1234. Let's check it out in the browser, and boom, our app is compiling and working nicely. Now, this is a very simplistic example, and things get a lot more interesting when we start passing more complicated shapes as flags to our program. What we're going to do is use a free and open API that gives us the bank bill swap rates, or BBSW, from the ASX, that's the Australian Stock Exchange. And this is a nice API, and if we hit the endpoint here, you can see the JSON that we get back. In this JSON object, we've got strings, we've got floats, even lists of other objects here. And if you can decode this in Elm, then you can pretty much decode anything. So this is going to do nicely for our example. So let's go ahead and make a fetch request. I'm just going to use the basic fetch, and I'll add this URL here. And we'll just do method get. And so that's the fetch. And of course, this is a promise. So I'm just going to do a dot then, and we will have the request, and I'll call response.json. This is another promise, so let's do another dot then, and this block we get the JSON data, and here's a good place to initialize the Elm program. Let's move all of our Elm code in here, and instead of the dark mode value for the flags, let's pass it the bank swaps. So here we can get rid of this and just pass it data. Perfect. Okay, so if we check the browser, obviously we are expecting the error state because our decoders would have failed to decode the new data that we're passing it. Let's have another look at the data in the browser, and you can see clearly that what we're getting back here. We can see that it has an object with a data key, and here we have an items key, and this is an array of objects. So let's start decoding this thing. So in the very first step, let's define as a type what we want to end up with. So from the browser, I'll just copy and paste some of this and chuck it in the file as a comment, so it's convenient to reference. Now what I want to be left with is the data, but not include the data key. So let's include all the values, and I'll create an alias here called data. And let's got two properties. One is date as of, that's a string. And the other one is items. And that's going to be a list of a type called item. Now let's create item type alias item. And the first property is going to be the ask, and that's going to be a float. And let's see if the LSP helps us out here. Let's do bid and get some autocomplete, and awesome. Yep, that worked out fine. Now we've got a couple of interesting values here. We have this tenor, which is a 1M down here in the data, if you can see, but this goes all the way to 6M. Now I know this ahead of time, so we can do something interesting with this type instead of just decoding it to a string. Let's leave it as a string for now, but yeah, we'll come back to this. Let's create a separate function to do the decoding. I'm just going to simply call it decode, and this is going to be a decoder of data. So decode equals, and I'm just going to change the alias here from JSON to decode. All right, back down here, the first thing that we're going to do is do decode at, and the first thing in that JSON is going to be the data key. So we can do JSON.Decode at data. So this isn't going to decode the data field. It's just going to decode what is the value of that key. All right, next thing, we want to decode.map to, and that's going to be the data. And the reason we're doing this is because there are two properties in that data alias there. Let's chuck two placeholders here. And we use decode.field, and that's going to be date as of, and that's a string. LSP is helping out. The next one's going to be decode field items. And this one's a bit more interesting. Let's make some space. This is going to be a decode.list. Let's create more space here. It's a bit nested. And again, we're going to decode map. This is an alias, and there's 6 properties. So we can pass it the item constructor. And let's put some placeholders here just to make it easier. I tend to lose track when I don't have these placeholders. And let's go through each field. So the first one is going to be ask. And the second one is going to be bid. And this is a float. Third one's going to be mid. And that's going to be a float. Then we've got decode.field method. And that's going to be a string. And then we have tenor. So, yep, tenor, and that's going to be a string. For now, we'll come back to this. And lucky last, we've got decode.field yield range. That's going to be a string. So that's all good. Now, I'm just going to quickly change the JSON here to be the alias that we set, which was decode. I'll just do a search and replace. Nice, save that. And then what we're going to do here is just copy this flags result. I'm going to call it flags01. And we're going to do pass it the decode that we just created. And then what we can do here is just do a log and see what result we got back. So let's do a debug.log data, and let's pass that flags result 01. Save that. Let's check it out in the browser. Open up some tools, console, let's refresh. And there you go. We're getting a data of OK, which means we have successfully decoded it correctly. Awesome. Good start. Now, because we're using these map functions here, let's just have a look at them here. So here we're using map6, and you can see that we are decoding 6 properties, and that corresponds to this item here, this item type. Now, what do we do when we run out of these map functions? Well, that's completely fine. You can still work around it, but it's a bit annoying to do. So one very popular package that was created to deal with this specifically is what we're going to use now. So let's jump into the console. So let's do elm install no-red inc / elm Json.Decode pipeline. So that, perfect. Now let's import it. Whoops, decode. That's going to be decode pipeline. And all we need from this is exposing required. So we just need that required field. This will let us do a lot of stuff. So here, instead of doing these map2s, we can just do decode succeed data. And instead of this field, we can actually just use pipes. So let's use a pipe here. Let's change all these fields to pipes. Oh yeah, we have to do required. And same with this here, we decode.succeed item. And let's change all of these fields to pipes. Let's see if I can do this. Required. And that did not work. Okay, my vim foo is not happening today. Let's do required. And let's see if I can do this one. Perfect. Okay, cool. Now, what I've got to do is just get rid of these extra parens. Save that. Perfect. And as you can see, you can have as many properties as you want on your types, and the pipes will just handle it for you. You don't have to do like map. I think it goes up to map 9 and then you run out of maps. Okay, let's now actually change this program to work with this new data structure we have and actually render something a bit more useful. So here, Ready is just going to take the data, and down here we'll be decoding this thing. We're going to get rid of that. Let's just make this flags result. And flags result will now return that data. And we don't need the 0 or the bool. We can just return data for that OK branch. Let's remove that. Okay, now this is going to break a few things. Let's do the update. Now the update is going to be easy because we're actually not producing any messages. So we can go ahead and just remove everything and just return command.none essentially. So let's remove this and we just return model command.none and that'll make that happy. No messages required or commands required. Here for the view, let's just remove these arguments and just do data. So we're getting our data for the ready model. We can remove all this stuff. Let's get rid of anything in the attributes and in the body. And here, let's be very simplistic, text ready, just to make sure that we know that we're compiling. Let's save that. And let's jump in the browser. Let's refresh. Awesome. Everything is compiling nicely. And now we can actually do something a bit more interesting. Now let's see if we can render something a little bit more interesting here for the items. In this div, I'm going to just use list.map. And I'm going to say view item. This function doesn't exist yet, but we'll do it. And let's pass it the data.items. Now code action should create this function for us. Yep, awesome. Let's go down to view item. Let's make this really, really simple UI. So just a div with some children. We'll do a h1, no attributes, and let's do text arg1.tenor. So that's going to be our tenor value. Let's do another div, and this will be our string.fromFloat, and this is going to be the arg1.ask property. Let's just fill in these other ones here. Nice. So here we can do our bid, our mid, and this is going to be yield range. And this is not a float, this is a string, so we can actually just get rid of this here. Cool, let's save that. And as you can see, we've got some more interesting UI rendering. This is great, but let's give ourselves another requirement. And instead of 1M or 2M, etc., we want something more like 1 month or 2 months. And let's jump back into the code and see how we can do this. Now, one way of doing this is we can use a let block. And let's type here tenor to presentational string. And we can do a humble if statement, arg1.tenor equals 1M. Then we can just render 1 month. If else arg1 tenor equals 3M, then 2 months. And that's going to be 1. Else, let's just do whatever. You get the point. We could just keep doing this for all the different values that it could be. And we seem to have an error here. And that's because it's not if else, it's else if. Save that. Now here in the H1, let's change this to be tenor to presentational string. Save that, check out the browser. Let's refresh. And okay, everything's come back as whatever. We clearly made a mistake. Let's jump back in. And that's meant to be capital M. And that's 3M. Okay. Yep. Okay, I did make a mistake there with the M's. I messed it up, but this is the case in point, is that when you're comparing strings like this, it's very tricky to get that right. And you might be doing this in different parts of the code base, depending where you need to surface this value. So we can make this experience a whole lot better and map these tenor values to a stricter types, because we know what they are. They're only going to be 1M to 6M. So we really know what they are. We can handle this at the decoder level. And this is going to be far less error prone, and it's just going to be a nicer experience. So let's check that out now. Okay, so what we're going to do is change this 1M to be an actual custom type. So let's create a custom type. We can just do that with type. Let's call it tenor. And here we're going to add all the variants. So it's going to be M1, M2, all the way to M6, M4, M5. Okay, so now what we can do is update our alias item, and instead of string, let's make this tenor. So we're forcing it to be a tenor. Now this is going to break our decoder, as you can see here, and rightly so, because here we're decoding a string, but really what's required for that field is a tenor. So how do we decode a tenor? What we're going to do is create a separate decoder function, toTenor decoder. Now this is going to take a string and it's going to return to us a decoder of tenor. Let's do toTenor decoder. Take that string. Now let's match on that string. So we'll do case string of, let's do 1M. And if it's a 1M, we're gonna succeed our decoder, decode.succeed, and return that variant 1M. And let's do it for the other one, for all the others. So that's gonna be 2. That's gonna be 2. Let's just add these in here. 3, 4, and 6. Let's do the same here. We're going to do 1, 2, 3, 4, 5, and 6. Now I'm going to save this just to get a bit of formatting. Yep, perfect. Now it's complaining because we need a default. For anything that's not one of these, we can say decode.fail and pass it could not decode tenor value. Nice, let's fix that. Yep. Okay, now that we've got that toTenor decoder, we can now pass that in. So here, what we're going to do is we're going to say decode.andThen. So what andThen is doing here is that it's decoding a string and then it's going to pass it to a function. That function that we're going to pass it to is the function that we just created because that takes a string and returns a decoder. So here we can say decode andThen toTenor decoder. And that should satisfy that. Now we're going to have to handle this in the view item. Let's do that here. So instead of doing the if statements, we can do a case on arg1.tenor. And this is going to be M1, 1 month, and let's just do all the others. M4 is going to be 4 months. M5 will be 5 months. M6 is 6 months. Let's save that. That's looking good. Let's now check out the browser, refresh, and you can see that we're actually getting the result that we want. And this is a much nicer way to handle strings in Elm. If you really know what they are, you can qualify them as a custom type, and it just makes your life a whole lot easier. So there's still string pattern matching, but it's happening at the decoder level. Now, the other value that's interesting here is the yield range value. Now, this looks like a float here, but it also appears as this dash down here. So it can be a float or a dash, and this is a really good candidate for another custom type. Now, for yield range, let's actually make this a maybe float. And instead, let's use the maybe decoder for yield range because it's complaining here. So here we're going to say decode maybe decode.float, and we'll just wrap these in parens because this returns a decoder. Nice. Okay, so same deal in the view. We're going to have to handle this maybe float. So what we can do is just wrap this in parens and do a maybe.map, and we're going to say string.fromFloat. And what we're going to do is pipe that to a function called maybe.withDefault, and then we can pass it the dash. So essentially all this is doing is it's getting that maybe float and then mapping it to a string. And if that doesn't work, it pipes it to the withDefault. WithDefault just takes a maybe, and we just say, okay, if it's nothing, just render a dash. Now, if we go back to the browser, okay, so what you're seeing here is it's a dash, which means we're not decoding this right because we know there are float values here, as you can see here. So let's see what we've done wrong here. If I jump back to the decoder, you can see that what we're doing is we're decoding a float. It's coming in as a string, not a float. That's why it's failing. So what we can do is just do a decode.map string.toFloat, and we can get rid of this maybe, and it's not a float that we're decoding, it's a string. So again, what's happening here, and it kind of looks in reverse, so it looks weird. We're decoding a string, and then we're trying to map that string to a float. That might work, it might not. That's why it's a maybe. Float or nothing if it doesn't work. Now, if we open up the browser again, let's refresh. You can see we've got everything working perfectly. Very nicely done. Now, don't worry if this doesn't immediately make sense. Decoding stuff is actually quite hard to wrap your head around initially, so definitely play with this and stare at it, and I promise you it's going to click. Just play around with it. So today we learned how to use decoders to decode more complicated JSON shapes. And we did that with the standard Elm library, as well as a third-party package called Elm Json.Decode pipeline. We also learned how to use custom types to map known strings into very useful data structures that we can use in our programs. I had a ton of fun walking through decoders with you, and I really hope that you feel confident enough to implement them in your own projects. Thanks.